So let me still continue. Now let's consider joint C. At joint C, we have K3, 3, 2, and 2, 3. At this joint C on the space diagram, this joint C, we have K3, this is K3, this member, 3, 2, this is member, 2J, this member. Okay, so we move straight to the vector diagram. The first joint there, or member we have to consider is K3. Now K3 in the vector diagram, this is K and this is 3. So we'll be moving from K to 3. So it will be this direction from K to 3. Then we come back to joint C. At joint C, this K3 is this member. So at joint C, it will be pointing to this direction because K3 we move from this K to this 3 direction. Now we have another member 3, 2 at joint K. 3, 2. Now we know 3, we know 2. So 3, 2, we move from down to top. 3, 2. And we come back to the space diagram. 3, 2. This is 3 and 2. At joint C, 3, 2, we moved up. Look. 3, 2. So we moved up. So at joint C, this is 3, 2 member. And at joint C, we have to move up. So the arrow indication at joint C on member 3, 2 would have to be up. Another member at joint C is 2J. 2J. 2J, we come back to the vector diagram to determine its direction. 2J. This is 2 and this is J. 2J. So this time around we are moving in this direction from 2 to J. So at joint C, 2J. This is 2J. 2J. This is the member. At joint C, the arrow will move in this direction. At joint C, it will move in this direction because 2J will actually move from this to this. Let me do the last joint and we move on, or you do the rest because we'll be following this a similar fashion for all the joints. The last joint I want to touch on before you continue with the rest is joint D. Joint D, you have K6, 6, 5, 5, 4, 4, 3, and 3K. The first joint is K6 at joint D. This joint D. K6. K and 6. This member. K and 6. Do not consider this junction. We are at K. At joint D rather. And we are considering K6. So K6 at joint D, move back to the vector diagram. K6, this is K, and this is 6. So K6, it will be this direction. So when you come to joint D, K6 member is this, the direction will be in this form. At this joint, it will be in this form. At joint D, we have 6, 5. 6, 5. So 6, 5, you come back to the vector or force diagram. This is 6 and this is 5. They are all lying on the same point, 6, 5, on the same point. So at joint D, 6, 5, there will be no direction of force in the member. No, there will be no direction of force. There will be no direction of force because 6, 5, when we determined its magnitude, 6, 5 magnitude or 5, 6 magnitude, we are 0. So definitely the nature of the force will be dash because 6 and 5 all lies on the same point. The next joint member at joint D is 5, 4. 5 and 4. This is 5, this is 4. They are all lying on the same points. So joint D, this joint 5 and 4. 5 and 4. What arrow will be here? Is it down or up? We've gotten to know that they are all on the same point, so it's 0, so there will be no arrow. So 5 and 4, this member is not going to have any arrow, nothing. The next joint is 4 and 3. 4 and 3 still are on the same points. Once again, when you come back to 4 and 3, this is a member. Adjoint D, is it going down or up? It's 0. There will be no direction because the member itself has a force of 0, which is a 0 force member. Our last member here is 3 and K at joint D. 3 and K. This is 3. This is K. So 3 and K, we are actually moving this direction. So at joint D, 3 and K, 3 and K, which is this member. At joint D, we'll be moving in this direction. Considering joint D, 3 and K, you'll be moving this direction. So the arrow will be this because you move from 3 to K. So this is actually what you'll be doing for all the various joints to determine the direction of the force in the members. Having gone through that, we are now coming to use the direction of the arrows to determine whether the member is in compression or the member is in tension. So determining the direction of the arrows, we know that in normal forces, we have the tension force and we have the compression force. And the tension force have these arrows, meaning the force is putting the member in tension. It is stretching it. In compression, it is actually compressing the member. So this is how the direction of the arrows will move to indicate that the member is being compressed. This to indicate that the member is being stretched, the member is in tension. But this definition that we know is different or is the opposite when we come to determination of the nature of forces in members. Let me give you an example. With member J1, this one, with member J1, we realize that the arrow here is pointing down. When you come here, the arrow is pointing up. So we can say the member is in tension. Yes, it's true. It's true that the member is in tension. But the nature of the force is actually the force acting on this member. This is the internal force of the member. It is stretching the member. It is stretching the member because the member has realized that a force is coming on it. There's a force coming on it. There's a force compressing it. So if there's a force compressing it, the member itself has to exert another force to counteract the force acting on it. So the force it is exerting or giving out is a tension force. That is not the force we are considering to determine the nature of force acting on it. The nature of force acting on it is actually a compression. So this member will be under compression. The arrows here indicate that it is the member, the force in it is tension, meaning it has realized that a certain force is acting on it, a certain force is compressing it. That is how come it is exerting its own force, which is tension force. So don't consider the force it is exerting, but consider the force acting on the member. It is true that this direction indicates that the member is in tension, but we look at the force that has caused this member to release this tension force. And that is the force we record because that is the force acting on this member. So instead of our normal force being tension, it means the force acting on it is compression. So J1 becomes a compression. The force acting on it becomes compression. J2, when we look at J2, this is J2. This is J2 once again. When you look at the arrows at the ends of J2, this and this, J2 is exerting a tension force because J2 has realized there's a force acting on it. There's a force acting on it called compression force. So it has to exert its own force to counteract the force acting on it. So don't tell me J2, because the arrows are pointing in this form, it means it's in tension. Yes, the member itself is in tension, but we are not considering the force in the member. We are considering the force acting on the member. And it is releasing a tensional force, meaning the force acting on it is compression. So J2 is also a compression force. So this is what we do to determine the forces acting on members. Let me look at one member in tension. 5M. This is 5M. It's in tension. Where is 5? This is 5. This is M. So 5M here is in tension. We can see the arrows here at this side and at this side coming together. It means the member is exerting a compression force. Look at the arrows. The member is exerting a compression force. Do not record the force it is exerting as the force acting on it. No. When it's exerting a compression force, it means the force acting on it is in tension. So 5M becomes a tensional force. Simply, it's opposite, is the other way round. So follow these principles and work out the nature of forces in all members. First consider, in summary, you first consider the joints in the truss. And then you consider at every particular joint a clockwise rotation for all the members. When you list all the members or when you keep them in your head, you follow the order in which it has been lettered to look at a direction in the vector diagram. After looking at a direction in the vector diagram, if it is coming down, if it is going up, you keep it in mind and you come back to that particular member, considering a specific joint which you took. So at the end of the day, you realize that when the first joint A, when the direction was coming down at A, automatically at the other side of that same member, the joint will be in opposite direction. So look at this joint and look at this joint, how the member is, how the arrows have taken its place. So when we realize that here the joint is moving, the arrow is moving down at this joint, automatically the next side of the member, the joint will be moving in the different direction. So take notice of them. So when we redraw this truss, as an engineer, you should be able to minimize costs. So with this analysis, you have realized that the actual truss should be something like this. The actual truss should be something like this. It means there are some members which shouldn't be there because they are not serving any purpose. And these are the members with the zero force. So a member like 3 and 4 will have to be removed. A member like 4 and 5 have to be removed. A member like 5 and 6 will have to be removed because we realize that 3, 4, 4, 5, 5, 6 are all zero force members. It means there is no force acting on it, and they don't even have any arrows, meaning they are also not exerting any force. So what happens is that it becomes waste at its position. So you just have to